Hi guys, today I'm going to do a brief video on using the power rule to calculate derivatives. So we use the power rule when we have to take the derivative of some variable, whether that be x, y, z, or whatever letter or variable you have, and it's raised to some power. So for example, something like x to the fifth, right? And I have the formal definition written up here. They're basically two steps, right? So the first step, you're going to take your exponent and you're going to multiply it down here in front of your variable. And step two, you're just going to drop your power by 1. So it's going to become n minus 1. And let's go through some examples to make this a little bit more clear. So here I have f of x equals x to the fifth. And if we want to take the derivative using the power rule, we're going to follow the same two steps, right? So first, we're going to drop the exponent down and multiply it in front. So we're going to get 5x. And then, simple step 2, we're just going to drop the exponent down by 1. So 5 minus 1 is 4. And there you go, you have your derivative, right? And don't get intimidated by large numbers either. So instead of 5, say you have 18 or 100, whatever really number you have, the steps remain the same. So, for example, right, f of x equals x to the 18th. Step 1, we're going to multiply the exponent down out in front of the variable. So we're going to get 18x, and then we're just simply going to drop the exponent by 1. So 18 minus 1 is 17. And there you go, you have your derivative. So that's basically how we solve power rule problems. And sometimes you may come across problems that have coefficients or numbers in front of your variable. So maybe you can have something like this, 2x cubed. Right? And notice there's a 2 there, but don't worry, our process is going to be exactly the same. So we're just going to pretend that 2 is not there, and we're going to multiply the 3 down out in front like we normally would, right? So we're going to get 3 and then times our 2x, and then just as we normally would, we would just drop the exponent down by 1, so we get 2. And we can clean this up a little bit. 3 times 2 is 6, so our final answer would be 6x squared. And we can go through another quick example of something like that. Maybe we have 4x squared. Same process. We're going to multiply this exponent down out in front, so we get 2 times 4x. And our simple step 2, we're just going to drop that number down by 1. So 4x to the first. And as you know, anything raised to the first, you don't really have to put the 1 there. So we can clean this up and we can arrive at 8x, which is our derivative. And as you guys get more involved with these questions, the multiplication here is going to come more naturally, and you might not have to write out this step. So you might just say 2 times 4 is 8 and then drop the exponent. So that'll come with practice, not to worry. And sometimes you guys may get faced with negative exponent questions, but not to worry, we'll walk through those, and it's essentially the same process like it's always been. So say rather than 4x squared, you had 4x to the negative 2. And again, your process is going to be exactly the same. So we're going to, first step, multiply this exponent down out in front of whatever we have here. So we're going to get a negative 2 times our 4x. And we're just going to drop that number down by 1. So here it may be a little bit confusing because you have a negative number. So just be careful. Negative 2 minus 1 is negative 3, not negative 1. So drop that down to negative 3. And then we just clean up like always. So we end up with negative 8x to the negative 3, right? And here I just want to bring up, we do have an exponent rule. You guys probably learned this in algebra, but just to recap really fast. When you have a negative exponent, so say you have something like x to the negative 2, this actually equals 1 over x to the 2, right? So you would just make that exponent positive and put it under a 1. So if you wanted to rewrite this, you could rewrite this as negative 8 times 1 over x cubed, or just negative 8 over x cubed. And depending on your class and your teacher, you might not have to simplify this down that way, and this might be perfectly acceptable, but just so that it's in the back of your head. So I'm going to finish off this video with one last example, and this time we're just going to look at a quick example where we have something in a fraction form. So maybe something that looks like 1 over x to the 8th. And our job here, our first step, is to convert this into a form that we can apply the power rule to, right? So using the rule we discussed previously, 1 over x to the 8th is the same thing as x to the negative 8th. And so now we have this in a form that we can apply the power rule to, just like we have been for the past several examples. So we would do the same thing. We would multiply the exponent down out below. So we would get negative 8x, and we would just drop that exponent to the negative 9th. And again, this form might be perfectly acceptable if your teacher or class insists that you have it in fractional form. No worries, we'll just use our rule up here and we'll convert this back into fractional form. So this will be equal to negative 8 times 1 over x to the positive 9. Again, we use this rule up here to convert x to the negative 9 into 1 over x to the 9. And then just to clean this up, we would get a final answer of negative 8 over x to the 9th, right? So there you have it. That's the basics of the power rule. I've also made a separate video with some examples that you guys can use to practice. Some of them are a bit more challenging, so hopefully it gives you guys that variety of simple through challenging. I'll link the video down in the description box below, and as always, let me know if you guys have any questions down in the comments section. Hope this helped, and see you guys soon.